For the coming session, I'm going to be talking about the software ecosystem for open hardware and the Disaggregate Lab virtual tool. And my special guest is Wiwynn from Facebook. So let's get the story begin. As a software company's IT personnel, to handle the company growth on the IT infrastructure is a pretty painful process. There's three major obstacles that are causing the pain. First is the resource constraint, which including time, hardware, and money. Second is to pick and build the right software solution for the company. Third is the scalability, which to pick the right software and hardware vendor, which has capacity to sustain the future company growth. So with this in mind, this Disaggregate Lab is to provide open hardware with free network access to promote open compute concept. Both hardware and software can be tested and validated in the platform, then make this open to the public. At the end, this Disaggregate Lab would like to achieve a complete ecosystem that makes the cloud computing solution easy, engaged, and friendly. To further elaborate the concept and the story, we're honored to invite Iran from Facebook to share with us his experience about this Disaggregate Lab. Let's have a welcome for Iran from Facebook.
Thanks, Jay. Thanks for having me here. So yeah, my name is Iran. I've been at Facebook for quite a while. I joined when we just started this journey, if you will, of open compute, open source hardware, and disaggregated solutions. So you know, when we started off, it really came from a place of needing to flex what our infrastructure was doing at a rate that was faster than what we could get from our suppliers. And that's really what kind of pushed Facebook and motivated us to try and do a little bit more on our own. And so in 2010, we built our first server. It was a compute server. We called it Freedom. And honestly, when we started out, early 2010, I think most people expected us to fail. Fail in the sense that they didn't think we would carry it to production. We were successful, and a year later did manage to start rolling that solution into production. And at that point, we kind of asked ourselves, okay, what do we do next? And that's when the idea of open compute came about. There's definitely, I'd say, some roots in the Facebook philosophy of sharing, of collaborating, in order to get a better solution, and you know, that kind of maybe comes a little bit from who we are as a company. But it was important to us when we founded it that it wouldn't be a Facebook-only thing, and so we made sure to partner with folks like Rackspace, Intel, Goldman Sachs. Later on, Microsoft joined us as well, to be present on the board and to really make this an industry effort with multiple contributors. You know, it's really grown kind of in this perhaps exponential curve, if you will, over the years. You can base it on a variety of metrics, whether it's number of contributions, whether it's quality of contributions, whether it's the scope of technology that OCP addresses, whether it's the depth into the stack that OCP addresses. It's continued to grow, it's continued to expand and provide more value, more solutions, and also make its way into more adopters. I think the most critical piece for us in this whole philosophy is choice that is attained through disaggregation. So if you remember where I started this conversation, the problem was we couldn't move quickly enough, and we didn't have enough flexibility to modify our infrastructure to meet the needs of the workload so that the ROI on the infrastructure was effective. And that's really what we're trying to advance, if you will, or push in many ways through OCP, is bring a wealth of solutions that have open interfaces that are built to, at least as a standard, if are not an official standard, that allow those who have deployed this technology to make their own decisions on how they configure it, how they run it, how they might modify it over time or retrofit it or evolve it, perhaps change the designs, etc. And again, the reason this is so critical is for a lot of web scale folks, or for a lot of folks that are running modern applications or modern networks, you really don't know what tomorrow brings. Workloads evolve so quickly. Facebook decided to turn video on one day. That definitely posed a challenge for some telecom networks in different places in the world. Those sorts of things will continue to happen from various entities who are basically using our networks and our data centers. And the folks who power that, you want to be able to adjust, you want to be able to flex to that and continue to run efficient infrastructure. And that's why disaggregation is so important. It's the ability to say, my workload changed like this, moved a little bit to the right, moved a little bit to the left. From my 10 different elements that I have in my stack, I really need to only modify one to address this, and this is how I need to modify it. In the old paradigm, all elements of the stack were supplied by one solution provider, and so making that change was immensely hard. In the model of disaggregation, you're in control of making that choice. I think one thing that's important to highlight is disaggregation is not about, if you will, trying to eliminate the ability of anybody to compete. It's all about expanding the possibilities to compete, right? So this is not about beating up some classic black box vendor or some classic OEM. No, it's enabling others to compete with them just as effectively. But if those vendors can also provide effective solutions that can be quickly modified, can be easily adapted into different pieces of the infrastructure, there's no reason not to take them in as well. So disaggregation is really about expanding the opportunity for innovation, leaving choice for the operator, and really making sure that infrastructure is evolving in the most efficient and quickest way possible. So hopefully that's a helpful intro, Jay?
Thank you, Yaron. I think the key here is that the lab themselves providing a platform that's open to public to prove the concept of yours and make sure that the same as hardware-wise and can apply and then be available if you guys needed them. And so let's now go to the next page, which will be showing as for to build a full ecosystem which includes both hardware and software is the vision of the Disaggregate Lab. To make the ecosystem better and stronger, each party needs to be putting participation and effort. As for open hardware-wise, in the vendors such as Wiwynn, Menalox, and Citycom, as for OS and software provider like OpenStack, Canonical, Mass and Juju, Red Hat Cluster, Storage, Azebo, CloudForms. For the solution provider like NetApp, ONTAP Select, IBM Spectrum, Weka.io, Hedvig, Red Hat Cluster, FS, and Ceph. For the cloud system provider like the CS Square and Equinox, more partners joined and contribute to this, the ecosystem will be more attractive. Such encouragement will provide the incentive to improve and make the system more complete. Then the industry will become benefit with the result. So the road for each vendor in the software ecosystem-wise, and for hardware vendor, contributing the hardware and components, continue working with the software vendor to validate their software solutions. As for software vendor-wise, and validation the software-defined solution to ensure that the resilience being built into the higher software layer is stable and confidential. As for all size companies or CSPs, adapting the next generation of the infrastructure design and choose from multiple options is the goal for this Disaggregate lab. So now we have a short, brief video to kind of give you guys a glimpse of the lab looks like.
In 2011, Facebook, with a variety of other industry partners, founded the Open Compute Project. The idea of the Open Compute Project was to create a community where various deployers and developers of data center technology could bring their technology and share the way that they have developed and deployed it with other members in the industry. The hope was that together, by sharing what we were learning, we would be able to drive innovation in the data center space at an even faster pace. Over the years, Open Compute has grown quite a bit, and we have seen a variety of meaningful hardware contributions come into it. One of the great powers of Open Compute is disaggregation. Disaggregation is the idea that as an operator, you can deploy the combination of hardware and software that suits your needs best. By doing so, when your workload evolves and morphs over time, you have the flexibility to adapt your infrastructure exactly as best fit for your needs without having to modify greater pieces of your infrastructure. However, disaggregation can also be challenging. One of the challenges with OCP adoption is the ability to bring the right software and hardware together. The power of disaggregation means you have the choice of hardware and software that best fits your workload, but it also means that you have to bring it together successfully. What we noticed within the OCP community was that some adopters were struggling to validate a software stack while also trying to figure out how they would fit the hardware into their infrastructure. In order to help them sidestep this challenge and evaluate the effectiveness of the OCP hardware as they were figuring out its fit for the infrastructure, we founded the Disaggregate Lab. In the Disaggregate Lab, we have a variety of OCP contributed hardware available to adopters to trial, and they can run their software stacks as well as their workloads on top and get to know the OCP solution and validate its effectiveness before they have completely converted their hardware infrastructure. When we first opened the Disaggregate Lab, we hooked up with a couple of partners from the industry in order to demonstrate a full stack working. The first partners that we worked with were Canonical and Red Hat, who demonstrated their solutions working on top of OCP gear. You can see our OCP rack right over here. When we opened up the Disaggregate Lab, Facebook contributed some of its own gear. And we also got help from our friends in the OCP ecosystem. Specifically, Silicom, Mellanox, and Wiwynn also contributed hardware.
Hi, this is Jay from Wiwynn US. So we're here to break down furthermore detail on our rack configuration. So on this rack, our top zoning, we're containing 2 U3 nodes setup, and then each node that we're able to put facing 6 hard drives in, and Bravo CPU with 128 GB of DIMM, and the NIC is Meslin dual port 25 gigabit. We also have a dedicated of the management port, which is 1 gigabit. For our middle zone, focusing on each individual nodes connect into one single tray of our knobs. And each tray containing 15 drives total. And then the tray themselves with 12G of the SOX expander board and with hot pluggable feature phase in. As we can see now, the data light is still on. So we didn't interrupting any kind of data interruption here. So we are able to unplug the drive and wait till the drive calm down. So we'll be able to remove the drive and replace them. At this moment, our data light is still on. That's for hot pluggable features. So the bottom here then we have our lighting project, which is J-box solution, and currently it containing still 15 of the NVMe Intel SSD drive in it, but we can also using the adapters facing the M.2 format, so we can have 60 of the M.2 NVMe drive to face into the solution. For the rack configuration, our engineer has some specific platform design phase in. On the top zone right here, then we're more focusing on container and job tracker with the 4 hard drives in, with the CPU, 128GB DIMM, and all these things being included in here. The middle one is more toward the Hadoop storage solution. And then right down here in this segment right here then is for high compute, and over down the bottom then, down here we have storage head, and then we'll have more detailed explanation within our presentation file.
Once we had the hardware in, we quickly got to work, and we focused on building a disaggregate storage software stack, demonstrating a variety of solutions from various major players in the storage ecosystem. The first software solution we tested was NetApp's ONTAP Select. We got it working on the Leopard compute servers and the Knox JBOD storage systems. Following that, we got to work with IBM Spectrum Scale's distributed storage solution, which we also had running on top of Leopards and Knoxes without any issue. We also had a number of flash-based solutions that we showed. Specifically, we had demonstrations from Accelero, Weka.io, and Hedvig running their software solutions on top of our Ava flash card, which is basically a PCI Express interposer to M.2s slotted into the Leopard compute server. Finally, we had Red Hat demonstrate their distributed storage solutions on our OCP gear as well. Specifically, they showed GlusterFS and CEP running on our Leopard Knox combination. We would like to invite more folks in the ecosystem to join us in the Disaggregate Lab to demonstrate working software solutions and to trial various cloud workloads. We are happy to share our space and look forward to the ecosystem growing and innovating even faster.
To the software solution that I've been testing. So the coming few pages, I'm going to be further detailed to break down the configuration of the rack as you've been displaying prior. So the total rack themselves containing total 25 nodes. And with these 25 nodes, then we have summarizing of 5 different user scenarios. We try to avoid I try to avoid the redundance, so let me introducing the common capacity we're using for the DIMM size, and all 29 nodes, they all come with 128 gigabyte capacity, and the manufacturer is Samsung. And as for the NIC card-wise, and Meneloc's dual port 25 gigabit. And then for the HBA, we're using the LSI 9300-AE. For the RAID, we're using the LSI 9380-4i4E. So come down to, as you can see, the top zoning, we're using container usage. And then next to it is Hadoop name and then job tracker. The next zoning is called Hadoop data. And we have high compute, and the bottom is storage head. So the detailed specs on those, for our switch then, the Tor, we have the LN140, which is our homemade switch, has the 32 of the 100 gig, and then 16 of the 32, and then 12, 48 total. 32 and 16. So that would be 100 and then 40 of them. And then for the management switch, those are Juniper EX3300. Those are management switch. For the top one, the container usage-wise, and we use the Lipper systems with the Intel CPU E5-2683 16 cores, and with 4 of the Toshiba 1.2 terabyte SAS drive, and those of course in LSI 9380-4i4E RAID control. And then over down the, as you can see, the high compute node-wise, we're using the Lipper-V version, which will be the dual hard drive support. And with the Intel CPU E5-2690, those are 14 cores, with 2 of the Seagate SATA drive, 2 terabyte, and with 9300-AE HBA controller. And for our Hadoop job tracker, the same as the container usage, it's come with the E5-2683, those are 16 cores, and with 4 of the Toshiba 1.2 terabyte SAS drive, and LSI 9380-4i4E RAID control. For the Hadoop data, then we're using the E5-2690, those are 14 cores, and with 2 of the Seagate 2 terabyte SATA drive, and come with the HBA controller. We would like to also use this time to introducing our component partners. To achieve this total rack configuration build up, we need to thankful to our Intel Xeon family, which is E5-2600 series, and also the Intel P3500 1.92 terabyte SSD, Samsung 16 gigabyte memory, Toshiba 1.2 terabyte SAS drive family, Seagate 2 terabyte SATA hard drive family, and also Meneloc's MCX4421A dual ports 25 gigabyte NIC. So now I'm going to break down to the total rack capacity wise. For the CPU, total core is 856 sockets. Our memory total 3012 gigabyte. For system hard drive, total 80 terabyte. For NVMe, total is 57.6 terabyte. SAS for our JBOD, 240 terabyte. SATA will be 480 terabyte. For the power consumption wise, and under the loading of 85%, we kind of estimating with 11 kilowatts on those. So this is a breakdown of our Wiwynn's open rack at Disaggregate lab. So if anybody interested in would like to give it a shot, feel free to contact us. So the next section we have over here is still going briefly over with our resource pooling. So now this is kind of brief back to the early morning presentation by Ethan. So Wiwynn's rack not only provide open hardware to our partners, We also have Wiwynn Cluster Manager and Intel RSD available to the public for the tryout. This page demonstrates the block diagram of Wiwynn management topology. Like the previous presentation mentioned, Wiwynn Cluster Manager combined with the Intel RSD has become a complete management tool to monitor and allocate all hardware resources as a group. As you can see now in this case, our pod manager underneath that there are 6 different modules that on the background. And of course, in our UI, we're leveraging with the Wiwynn Cluster Manager as a whole in this case. So our next page here is the installation process, and these are on the backgrounds of it. And then when you guys try to access with the evaluation, you won't see this. You will simply see the front UI page will be coming next. So I'm going to be just jump over here, and then as for detail, then please feel free to discuss with us. We'll provide you more further information on those. And at the end, this will be the UI that brought in front of you while you want to evaluating our management tool. And this is how it looks like. So we wanted to also use this chance, a full way to grow software ecosystem using Disaggregate Lab. One is by contributing the hardware and components, and also the user can working with software vendor to validate their solution. As for software provider, then validating the software-defined solution to ensure that the resilience being built into the higher software layer is stable and confidential. And of course, and for our service provider, adapting the next generation of the infrastructure design and choose from multiple options. So this is pretty much the goal of our Disaggregate Lab. So if you are a current or a potential adapter of open hardware with an interest in a particular software package or a software vendor considering certifying on our open hardware, please feel free to using the below email address, contact us, and we'll get it going for you guys. So the above is my presentation, and thank you very much.